Swayam Prabha. Digital India. Educated India.
So, last class I have discussed how we can determine the total soil reaction force which is acting on the side wall of the well, and that expression was determined as P. So, this is the P expression and this is the side this is the P which is acting on the side wall of the well, and there will be a friction between the side wall of the well and the soil, and that is mu dash into P. So, now there will be a base reaction also, okay. And before that, so what I will calculate. So, because of this P which is acting at the side of the well, so there will be a moment will develop at the base of the well, because this P is acting. So, there will be a moment. So, that moment is, if I tell that moment is M P. So, that means, if I say this is the M P, where M P is the moment of P or due to P at the base. Okay. So, that M P will be equal to, again we have a stress, that is L into sigma x. Now, we have to apply the lever. So, what is the lever? Because we are taking moment, suppose in small segment, that force is L into sigma x, and then the lever arm from the base to that point is y minus dy, y minus y, d minus y. So, that means the lever arm will be at that point, this is d minus y. So, because of this small segment, the moment that will develop, for that moment the lever arm is d minus y. So, this is the force into the lever arm d minus y, and that we have to integrate from 0 to d. Okay, this is dy. So, we will get the moment of the total moment because of this P at the base, and so that means we can write that sigma x is this value m k v d theta. So, that we can write this is m k v theta, then L by d, because we have multiplied by L divided by d, then this is 0 to d along the depth, then there is a y term also, there is a y term. So, this is y, yeah, there is a y term y, and then d minus y to the power square, and this is dy. So, now after integrating this term and then the putting the limit and the simplify this, then we will get this M P is equal to m k v theta into I r. Okay. So, this is your I r, or I can write this is I v also. So, because later on I have to use one I r. So, we can put this is okay, you can put I r or you can put I v. So, I am putting this is I v. So, you can put it is I v. Okay. So, I v is this one. So, here also it will be I v, because later on I will use one I r part. So, this is I v. So, where I v is equal to L d cube divided by 12. So, this is the expression of M p. So, that means the M p is equal to M k v theta I v, and I v expression I have given. So, next one is that soil reaction, or this was the soil side reaction, this is soil base reaction. Okay, to do that, so if I draw this figure, that this is the base of the well or the cross section of the well. So, this is the base, where this is the B and this is the L. Okay. Now, as I mentioned, I have shown this well is rotating. Okay. So, that means there will be a point of rotation of the base also. So, that point of rotation is, say, this is the point of rotation, this is the point of rotation, C is the point of rotation, and that C is at a distance of, say, x c, capital X c, from the center of the well, and we have considered one small segment in the well base whose distance is capital X from the center of the well. Okay. So, that means the amount of rotation of the well base will be, this is your initial position, this is the initial position. Now, after that, after the rotation, this is the rotated position of the base. So, that means, if I use the different color, so then I can say, so this is the rotated position. Okay. So, that means, here the rotation again will be with this point. So, the amount of rotation, again this is the theta, and this is the point C again. Okay. So, this is the amount of deflection of the base. So, if I take again a small segment here, so this is original and this is after rotation. So, because of that, so there will be a stress difference at the base of the well, because it is rotating in this direction, in the towards the right direction. So, that means this will be the stress distribution at the base of the well, because it will not be uniform, because it is rotating, because of you are applying the horizontal load. So, this is Q max, this will be Q min. So, this is the pressure distribution at the base, and this is the deflection at the base. This is the base cross section. So, now the vertical deformation. So, because this is the vertical deformation at this edge and this is the vertical deformation of the other edge. So, these are the vertical deformation, this is the deflection, or I should say vertical deflection, vertical deflection at the base. So, that means the vertical deflection at a distance of, this is from the center, is x c plus x, at a distance of x c plus x from the point of rotation will be how much? Because the amount of rotation is theta and the distance is x c plus x. So, that small one, this curvature will be r theta, r value is how much? R value is x c plus x, this is the theta and the deformation is small. So, that is why we can consider it is a straight portion. So, that is why we can take this total deflection will be x c plus x from the point C into theta, theta is the point of rotation. So, because of the rotation, the vertical soil reaction sigma y will be how much? Sigma will be, this is the deformation is this amount and we know the kV, that means the coefficient of vertical subgrade modulus. So, that means that stress that will be k into the deflection. So, this will be the kV into that deflection plus x into theta. Okay, so, this is the sigma y at any distance from the point of rotation, or I should write sigma y is kV x c plus x into theta. So, because of this rotation, we can write that what will be the base moment that will develop. So, the moment at base, so with respect to center of the well, and that is m b, that will be equal to, that means we have a vertical soil reaction is sigma y, and then so now if I want to take the moment that is generated at the base of the well, and that we are taking from the center, and we have a small, this is at the small segment, the stress is sigma y. So, sigma y is the stress and we are taking with respect to center, center means this one. So, distance will be x, center of the well, not the center of rotation or point of rotation, it is center of the well. So, that is center of the well, remember that, that is with respect to center of the well. So, that will be sigma y into x, and the x is the lever arm. So, if the stress is acting in this small segment and the area of this small segment is dA, this is the area of the small segment, then the total force will be dy into dA, sigma y into dA. So, that means the total force will be sigma y into dA, and then the lever arm is x, because that is from the center of the well. So, that means the, and then if I integrate that, then that will give me the moment at the base. That means the soil reaction for that small segment is dy, and then the area of that small segment is dA. Sigma y is the vertical soil reaction for that small segment, and then the area of the small segment is dy. So, total force for that small segment is sigma y into dA, and the lever arm is x. So, that is the moment. So, now this moment, what will be the limit? So, limit will be, because it is taking from the center. So, this right side is positive and left side is the negative. So, that means we can write this, the limit will be minus b by 2 to plus b by 2, because this is b by 2, this half portion is b by 2 and this half portion is b by 2. So, from minus b by 2 to plus b by 2, because center is considered as the origin. Okay, so, now we can write that this is minus b by 2 plus b by 2 and sigma y is kv xc plus x theta. Then sigma y, we can write that this is kv theta xc plus x into x into a. Okay? Or we can take kv theta outside, then this will be minus b by 2 plus b by 2, then I can take this is x square into dA plus kv theta, then minus b by 2, then plus b by 2, this will be xcx into dA. Okay. Now, this origin of the origin, that means this origin where we are taking this moment is basically the CG of the well, okay, or the base. Now, origin is at the CG of the base. That means this is the origin and that is itself the CG of the base. So, that means if I take a moment with the origin, so in that case this x value is equal to 0, because we are taking, because your CG of the base, on that CG this reaction will act. Okay, so, that means x will be 0. So, I can write in that case that integration x dA, because your origin is at the CG of the base. So, that means if I take the dA, the total area, and then the into x, so that case this will be 0, because your origin is the CG of the base. So, x dA will be equal to 0. Okay. And we can write that x square dA, that will be equal to IB. So, this IB is moment of inertia of the base of the well about an axis passing through the center of gravity, about an axis passing through the center of gravity, to the CG, and perpendicular to the horizontal force. So, that means this is a moment of inertia of the base of the well about an axis which is passing through the CG. So, that means here you can see at the origin that we have taken is the CG of the base. So, that means the total area into x, or the area into x if I consider, then that area center is the origin of the point from which we have taken the moment. Okay. So, that means that is why this term will be 0 and this is the I b, and then finally, I can write here that m b will be equal to, this term will be 0, first time will be 0 and second time there is a k v into theta, and this term will be and there will be, this is your there will be x c, and so this is x c into, so this is the 2 x, so that is x c into, sorry, this is this second term is 0. So, that means this is x into d y. So, this term is equal to 0, second term is equal to 0, and this first term x square dA. So, this is I b. So, this will be I b. So, this is your expression of m b. So, this total, this term is 0 and the second term is 0, because this x into dA is equal to 0. So, this will be the x square dA. So, that is I b, that is equal to 0. So, now the total summation of the horizontal force, or I should say the summation of the horizontal force. So, what are the horizontal force is acting in this well? So, you can see that there will be P is one horizontal force. So, now there will be a m b also, base moment, and as the well is acting, or there will be a W and there will be H is acting and P is acting. So, so there will be a friction at the base of the well also. So, that friction we have W, this is mu into W. So, we have a friction. So, that direction of the friction force, to indicate that direction we have multiply a term beta. So, that friction force is beta mu W. W is the weight of the well. So, that means the vertical force which is acting at the base of the well. So, W is the vertical force which is acting at the base of the well, and then there will be mu into W, that friction force, and to indicate the direction that we have multiply a term which is beta. Okay, because P is also acting, H is also acting. So, direction of the beta will be defined based on that. So, that means or value of the beta will be defined based on that. So, that means here we are putting these are then now these are the forces. Now, if I take these are the forces, then what are the horizontal force? Total horizontal force. So, total horizontal force, there will be H which is acting at the top. So, this is H, then P, and then this beta mu W. Okay. So, and then so this is, I should say this is W. So, now this beta mu, instead of writing W, I should write this is equal to W, because this is there is a W component and there is a upward component also. So, this is mu dash P. Okay, so, that means the friction force at the base, that is the total vertical into the mu, and to note the direction we have multiply one beta term. So, that value will be discussed later on, and so that means that this is beta mu, then the W is the vertical one and the vertical downward direction, and upward direction the side wall friction that is acting in the upward direction. So, we have taken the net downward force. So, that is W minus mu dash P beta into mu. So, now that if I write here, so this will be H. So, H is acting this way and now we have considered this friction, base friction is also acting towards the h direction, and p is the opposite direction. So, this is h plus beta mu w minus mu dash p minus mu dash p, that will be equal to p. Okay. So, now where w is the net or vertical force, or w is the vertical force, I should write downward vertical force acting on base, mu is the coefficient of friction between the base of well and soil, which is generally taken as tan phi, and mu dash is the coefficient of friction between the side wall of well and soil, so which is taken as tan delta. Okay. So, delta is the friction angle between the soil and the side wall. Okay. So, where delta is the friction angle between the soil and the side wall. So, now if we simplify this equation, then we can write that there is a term p also this side. So, simplify equation h plus mu beta mu w, and then 1 plus beta mu dash. Okay. So, here delta is the friction angle between side wall and soil. So, P also will get by this equation. Okay. So, now here we have taken the summation of the horizontal force. Now, if I take the summation of the moment, that is equal to 0, or the summation of the moment. So, that means, if I take the m, which is the total applied moment about the base of well. That means, if m is the applied moment. So, suppose in this figure you can see the m is the applied moment, m is the applied moment. Then what are the moment that are counterbalancing this applied moment m? Suppose m is the applied moment with respect to base. So, that total moment is applied with respect to base. Then what are the moment which is acting in the opposite to the m? So, that moment is mb, which is due to the base soil reaction, that is counterbalancing the applied moment. Then moment due to the p, which is the force due to the side soil reaction. Then because of the mu dash p, which is the due to the friction between the side wall and the soil. So, these three forces will, or these three moment will be, summation of these three moment will be equal to the applied moment. Okay. Because applied moment direction is from left to right, and the direction of the other three moments is from right to left. okay, or I should say the direction of the applied moment in clockwise direction, the other moments are in anti-clockwise direction. Okay, and we are taking the moment from the base. So, this moment due to W and then this W is acting as the center at the CG. So, and we are also taking moment from the origin, and origin itself is the CG of the well, and then the moment which is acting at the base of the well. So, these things we will not consider, because these we are taking moment from the base. So, now only 3 moments that we have to consider: the moment due to P, moment due to mu dash P, and moment due to this MB that we have already considered. The MB is due to the soil reaction at the base, P is the soil reaction at the side, and mu dash P is the friction resistance from the side and the soil. So, if I take this moment, applied moment, so this will be equal to the MB base moment, then moment due to P MP, then the mu dash P, and that will act as B by 2 at a distance of B by 2. So, this will act at a distance of B by 2, because this is B. So, this is equal to B by 2 where it is acting. Okay. So, now if I put these values further, MB plus MP plus mu dash P into alpha D. So, where alpha will be alpha D we have written in place of B by 2. So, this will be B by 2 D. So, alpha is equal to B by 2 D for rectangular or square case, and this will be equal to d0 by pi d for circular case, where d0 is the outside diameter of the well, d0 is the of the well. Okay, and D is the depth of well below the scour level. Now, we know what is the value of MB and MP. So, that we have derived. So, MB is kV theta IB, and the MP is M kV theta IV. Okay, so, these values I am putting here. So, MB is kV theta IB, that is MB, and the MP is M kV theta IV, then plus mu dash alpha, and what is P value? So, P value is, this is the P value, and there is a term D. So, this is 2 M kV theta IV. So, this P we are putting in that equation, this is the P value. So, this P we are putting here 2 M kV theta IV, and there is a term D, and in the P also there is a term D. So, these two will cancel. So, this is the equation. So, now if I take kV theta common, then this will be IB plus M IV, then this is M IB 1 plus 2 mu dash alpha, okay, because this is also IV. So, IV M we have taken kV theta. So, 2 mu dash alpha. So, we can take the MV theta, that is equal to M divided by IB plus m IV, then 1 plus 2 mu dash alpha. That we are taking as m by I, where I is equal to IB plus m IV, then 1 plus 2 mu dash alpha. Okay. So, now we have two expression of P. This is the one expression of P and this is the one expression of P. Okay. So, now we are using that expression, that we are taking that P is equal to, is given that 2 m kV theta IV d. So, that we are writing here 2 m kV theta IV divided by d. Okay. Now, kV theta is m by r. So, if I replace that, kV theta is m by I and this is IV by d, and remember that m is the applied moment. Okay. So, now we can write this is equal to m by r, where r is equal to, this is m by r is equal to d by 2 into I m IV, because this is replaced as m by r. So, r will be d by 2 I by m IV. Okay. So, now we have another expression of H. So, that expression is what? This is the expression. So, now if I write that expression, that P is equal to H beta mu w, H plus beta mu w divided by 1 plus beta mu w mu s. Okay. So, that we can equate with this equation. So, we can write that H plus beta mu w 1 plus beta mu s, that will be equal to m by r. That will be equal to m by r. So, we can write that H plus beta mu w, that will be equal to m by r 1 plus beta mu dash, or we can write that m by r, if I take H this side, this is H, then this will be equal to, if I take beta mu common, so this will be w, then minus m by r, and beta mu I have taken, so mu dash. And I have already mentioned what is mu and mu dash. Mu dash is between the sidewall and the soil, and mu is the base and the soil. So, this is the equation. So, finally, the beta expression will be that beta expression will be m by r minus h divided by, if I take mu common, w minus m by r into mu dash. This is the expression of beta. Okay. So, this is the expression of beta, but now beta, this expression is valid if this is in beta value is in between this. That means, beta value, if we have written beta here. So, that is why this as I have discussed that we have to give the value of the beta. So, beta is in between plus 1 to minus 1. If it is plus 1, then the direction is the same as I have shown. If it is minus 1, the direction will be the opposite, because depending upon the p value and the h value, this force direction may change. Okay. So, that means the limit of beta is minus 1 to plus 1. Okay. So, that we have to now apply here. So, that means beta is this is the condition and beta expression is given. So, if I consider that one, then I can write that m by r minus h, because beta value is now given plus 1 to minus 1. So, that should be less than mu w minus m by r mu dash. So, if I consider the beta should be less than 1, then this is the equation. If you consider beta should be or beta should be greater than minus 1, so then also another condition will be appeared. So, now these two conditions. So, if I take this one, then I have to write that horizontal force should be greater than h r 1 plus mu dash minus mu w. And if I consider the another condition, because we have two conditions, then h should be less than m by r 1 minus beta mu dash plus mu w. So, these are the two conditions we have to satisfy for the lateral stability of the well. So, this is our condition number 1, or there are two conditions. So, I should write one A and B. So, this is condition A and one B. So, that means we have to satisfy this condition that h should be greater than m by r 1 plus mu dash in minus mu w, and m by r 1 minus mu dash plus mu w. So, what is m? M is the applied moment, okay, about the base, and h is the horizontal force, okay, and mu are the coefficients, friction coefficient, w is the downward vertical force, and r value is given. What is r? R expression of the r is given here. So, this is the expression of the r. So, r is d by 2 I divided by m I v. Okay. And what is m, what is I, what is I v, all the expressions are given. So, we have to satisfy these conditions. So, this is the conditions, so that we have to satisfy. So, there are there are one more conditions also, okay, and there are not only one more condition, there are few other conditions also. So, we have discussed, or I have discussed only one condition, or there is there are two conditions. So, but there are other conditions also. So, we have to satisfy all the conditions when you check the stability of a well under lateral force. So, this is one of them. So, in the next class I will discuss the other conditions as per the elastic method. Then I will discuss the other methods also by which we can design or we can check the stability of well under lateral load. Thank you.